Hello and welcome to another lecture series of I have selected that I should start a lecture series on how I prepared my monomers, right? Yeah, how a monomer is prepared. Now, first of all, I would like to tell you what is a monomer or how a monomer is synthesized. So monomer is simply a simple molecule which is capable of combining with a number of like or unlike molecules to form a polymer, right? So this is the simplest definition of monomer ever heard. So this is the basic of it. So monomers are simply, they combine themselves to form the polymers. So there are a number of methods to form monomers, to synthesize monomers, but I have selected an general method to prepare monomers from the scientists called named as Marvel and Torquay. His papers, basically this synthesis of his monomers were basically they were published in American. It was an American Chemical Society's journal, and it's been there in published in almost in 1950s, 50s, and 60s. So I am following the same method to prepare my monomer, and I can explain you how monomer is prepared by following a general method by Marvel and Torquay, right? So for that, we needed a particular glassware and an assembly setup. So I set up an assembly that consists of course, a round bottom flask, right? A three-necked round bottom flask is needed because this reaction, it progressed or it goes on in an inert atmosphere. That means we need to put the nitrogen gas inlet inside that flasks, so to create that inert atmosphere. So for that we needed a three necks, and for the middle and for the first, one of the three necks we use for a thermometer to put in to record the temperature throughout the reaction. And number second one, that is the middle one, we use it for to put the condenser inside it, and the condenser is fitted inside that. And the third one at the right side one is used for the nozzle that is supplying nitrogen gas to the reaction mixture. So in this way, this reaction was progressed in the in the round bottom flask and in an inert atmosphere, and it ended up by giving me or giving us a beautiful product with a monomer that is called MBF. I called it MBF. It was one of my very initial monomers which I prepared, and then I use them further for preparing other compounds also from that, and which I'm not discussing right now. Today here I'm only to discuss my first monomer which I prepared, for that we'll be needing a few chemicals also, definitely, and that include of course glacial acetic acid was needed in the preparation process, and for that we used furfurylaldehyde, and I used trioxine, and I used crushed ice or distilled water, and then of course I used the glassware that I used was beakers, glass rods for stirring the reaction mixture, and of course the 250 ml flasks that were needed, which I just explained, and there were other glassware, that is measuring cylinders for using, for measuring all the chemicals in it. Okay, so basically this was as it was my first monomer following this process. So I was I was just following the method as it was being published in that particular journal. So but as I progressed with the reaction, when we have to, of course, a reaction is progressing or you are synthesizing a monomer, naturally you'll be needing some sort of a protonating agent, so, or a protonating acid is there required. So I used a combination of acetic acid and concentrated sulfuric acid for that, as it was recommended in that process. But when I added sulfuric acid during the reaction, it I mean, elevated, or you can say it speeded up the reaction process so much that and the compound quickly polymerized within the period of 5 to 7 seconds, maybe hardly 10 seconds, and I got a very hard product that was not even easy to, I mean, take out from that, scratch it out from that the flask. It stuck inside, and it was so hard that I couldn't take it out from that flask. So I had to change the flask, and I again repeated the reaction, and again the same thing happened. Then I, of course, got the idea that it is something to do with the sulfuric acid. I should omit sulfuric acid. Maybe it is a strong protonating agent. Maybe it is speeding up the reaction and the speeding up the polymerization process. So instead, I should only use acetic acid, and of course trioxane. So this was something which I wanted to tell you. So I used trioxane in this experiment. Now, initially, trioxane. What is a trioxane? Trioxane is simply a compound having molecular formula C3H6O3. Its color is basically white, and it is a solid in a solid state. Its odor resembles almost like chloroform. Its molecular weight is 90.08 grams per ml, and its melting point is almost 64 degrees Celsius, and boiling point 114 degrees Celsius. It's a compound having a 6-membered ring, right? And it's a cyclic trimer and of aldehyde and ketones. And it can be prepared when monomers go through acid catalyzed condensation reactions. Okay, and what could be the uses of this? It could be used as a fuel, right? And it could be used in the synthesis of plastics, and as, of course, as a binder also. So this was something about, I mean, trioxane, which I used in this experiment. So for that reason, I think that now I must design a slide share so that you can we can go through easily the steps I have chosen to by following that procedure by Marvel and Torquay, and I was successful in getting I ended up with a great compound, a great monomer, which I mean helped me out in preparing a lot of other compounds also. With the help of that one compound, I was able to synthesize a lot of other polymers, ship-based polymers, and resins, ship-based resins. So let's share the slide. Okay, so this is how I synthesize. This is my slide. So this is how I synthesized of course, my first monomer, that is MBF. I abbreviated it as MBF, that is methylene bisphosphorylaldehyde. Okay, so I think I forgot to introduce myself. I am Professor Dr. Moina Akhtar from Dr. Mchem Institute of Chemistry, University of Sindh, Jamshedpur. And today I'm here to share my experience as a researcher, as a scientist in synthesizing a series of monomers. And I think I was the first one from that institute who was in those days who was working on the monomers. So let's start with our first slide. So this is how I synthesized MBF, 4,4-methylene bisphosphorylaldehyde. Okay, so it was my first monomer, so I put it there. The heading is there for my first monomer. Okay, let's move on. Synthesis of 4,4-methylene bisphosphorylaldehyde MBF. So here it's simply, you can simply see here, I took almost 17.3 mLs of phosphoraldehyde. It was in the liquid state, right? And into it I added 12.5 ml of acetic acid, right? Now this mixture was formed by adding the acetic acid to the phosphoraldehyde mixture in a dropwise manner, and with constant shaking of the flask and with the constant swirling of the flask, right? And now I took another beaker. And into it I added 1.75 grams of trioxane, which I just explained. And into it I dissolved this trioxane into 0.62 mLs of acetic acid, right? And then I stirred that mixture, constantly stirring it, and it was dissolved within 4 to 5 minutes. I took in dissolving this compound. And then this mixture, this is mixture number 2, was added into the first mixture of furfuryaldehyde containing acetic acid in a dropwise manner again, and swirling the flask with one hand and pouring it from the other hand, and swirling it with one hand and again pouring it with the other hand. This is how I progressed it, and I added the whole solution, the second solution of trioxine and acetic acid to this furfuryaldehyde solution in a dropwise manner, and I took a little time. There was no rush, no hurry, and I took a little time, and then yes, I was successful in adding up the second mixture into the first one, right? Okay, now as I just mentioned that this was all going on in a reaction flask, so it was added, and the reflux condenser was set up, and then it was placed there, and I put the nitrogen nozzle into it, and into its third. It was, as I told you, it was 3 necks. So in the first neck there was a nitrogen gas cylinder's nozzle, and the second was condenser, and the third one was thermometer, through which I was constantly monitoring the temperature. The temperature was allowed to stay for about 90 to 95 degrees Celsius. So I maintained the temperature on the hot plate. I was using a hot plate, and I just arranged this assembly on the full hot plate. It was a beautiful, something to see. So as it was in the inert atmosphere, the reaction started. It progressed smoothly. Nothing happened. Nothing. You can say the reaction progressed smoothly. And I never, again had that same, I never faced that same problem again, that the compound started polymerizing again, as I never used sulfuric acid. Concentrated sulfuric acid was omitted. Okay, now I kept that, according to that procedure, I have to progress that reaction for the period of 24 hours, right? The 24 hours I had to reflux this on the hot plate with constant stirring. There was a magnetic bar inside that round bottom flask, so it was constantly, constantly stirring in the reaction mixture, and the process was supposed to be continued for about 24 hours. So now the next day, 24 hours. After 24 hours, I entered into my lab, and I saw that yes, it was going on perfectly, and exact after 24 hours, I stopped the heating, and then the mixture was, and I took in a beaker in which I put the crushed ice. A lot of crushed ice was there, almost 250 ml. I have also mentioned here, ice cold distilled water, about 250 ml was there, as it was water insoluble, so I took water as a solvent, and then I poured that reaction mixture to this mixture with the help of the glass rod, and with constant stirring, and addition of the compound and constant stirring, or you can say vigorous stirring with you can say with this glass rod. I was stirring that reaction mixture into that ice beaker, and then finally, after a period of almost 15 minutes, I started observing. First, initially it was a little bit, you can say, oily. I could see oil, floating over the top. And then I was, oh my God, when I'm going to get an oily product. So I'm going to get the precipitates, very difficult. It's very difficult to get the precipitates when you got an oily product. So I was a bit scared at the very first moment, but when I kept on stirring it inside that, with this crushed ice, it's starting, solidifying. It's starting, a little bit, you can say that oil was floating over the top. But yes, I thought I focused something, that let's wait, okay, because it was recommended that you have to keep it again for 12 hours. Right here you can see kept for 12 hours. So I again covered it with a filter paper and that reaction mixture, and I kept it at one side and leave it there for another 12 hours. And then after 12 hours, again I opened it up, and I saw that those precipitates that were floating there inside with the oil floating on the top were settled down at the bottom. They were at the bottom, and few of the droplets of oil droplets were seen floating over that, reaction mixture. So I got that idea that yes, my product is a little bit containing oil. It is a little bit oily. So I need to, use something that should remove the oil from my product so that I can get my precipitates. Okay, so yes. Okay, now after the 12 hours, I recovered the blackish product, washed with ether and ethanol. Now I simply filtered it by using a Buchanan's funnel, right? And I did the washing. Washing was done with 3 solvents. Of course, first, number 1 was distilled water. I washed it because I was not, my constant focus, my focus was on washing now, because washing was the very important step right now, as I observed droplets, oil droplets there. So they could disturb the process of precipitation. So I had to remove that oil. So that was in my mind. And for that, I need to wash my product very nicely. So I did the washing with distilled water, a little bit, 5 to 10 ml of distilled water. I poured it over my, over my reaction product, that filtered stuff, right? And then with the suction, it just sucked out all the, the filtrate was, sucked out, washed out with the distilled water. Then I used ethanol, that is ethyl alcohol. I poured it over the surface, and I again repeated the same suction process. It was again done, and yes, it was washed out. And then third, the very important one, diethyl ether I used. Almost 5 to 10 mLs of diethyl ether I poured over my precipitates, blackish precipitates. And yes, after putting that, washing that, I was left with beautiful powdered, or you can say powdered crystals that were, shining. I saw a big shine when they were washed with diethyl ether. I saw a little bit shine also in them. And yes, they were, very much black in color. And I was, very happy at that state that yes, my product is there. I am successful. I was like, oh my God, I got my product. Because this is the time, a scientist or researcher is very happy when after, so many steps, passing through all these steps, you are ended up with something you were looking for. So I got these blackish, I just wrote here, blackish shiny precipitates were recovered. I recovered them, right? I took them out on a sheet, different folds of filter paper, and then I kept it aside in the oven, as it was recommended that I have to dry it in the oven. So I kept inside in the oven, and and it was dried for the period about 7 to 8 hours. It was inside that oven at the temperature around 65 to 70 degrees centigrade. It was inside the oven. It was there, and then after a period of 4 to 5 hours, maybe 6 hours, I took it out and I recorded the melting point. Fine. I recorded the melting point. It was almost 300 and something like that. Okay, now I need to recrystallize it. Here I also wrote the recrystallization. So now I took the compound again and I recrystallized my product. And I again, filtered it off, and I was again ended up by getting the blackish shiny precipitates, right, of my product. They were more shinier, more clear, more, without oil, and they were all, powdered, and they were separated. They were not at all, gummy. The product was not at all gummy, though I thought that it is going to be gummy. It's going to be having oil in it, but no gummy. It was all, blackish and shiny, and beautiful crystals were there. So I was happy. I was very happy at that moment. Yes, because I accomplished something. And this is the time when a scientist is very happy, when you are getting the things you are looking for, you strive for, you worked so hard to get all, after passing all these steps, and after so many hours, you got your product. So, okay. So at that time, I recorded after again drying in the oven for about 4 to 5 hours, I again took it out and I recorded the melting point. It was above 300 degrees Celsius, right? So, and the compound structure was supposed to be like this. It was actually 4,4-methylene. This is the methylene group, right? 4,4-methylene based furfurylaldehyde, right? So this is this methylene bridge was formed, right? and I got this beautiful monomer in the end. This was the structure of my monomer, and you can simply here see it, right? The methylene group is at the 4th position, and aldehyde group is at 2nd position. So it's 4,4-methylene bisphosphorylaldehyde. Fine. So the structure of the compound was, you can see here, this was the structure of my compound. This is the picture of I took at that time. It was a beautiful blackish precipitates. I got in the end, after recrystallization, they were shining, they were beautiful, they were all separated. You can see here they are all separated, right? So they no gummy product. And then I recorded the melting point, and it was above 300 degrees Celsius. Okay, so now the question arises, how I've come to know that whether I have got my product what I was looking for. I treated it in the presence of trioxine. I used acids, and after I did refluxing for about 24 hours, the period of refluxing continued, and then I again kept it for precipitation. And how am I going to find out that whether I got my product, whether my monomer is actually 4,4-methylene bisphosphorylaldehyde. So I again went through 2 steps. That is, first of all, I recorded the melting point, and I was a bit assured that yes, my compound is heat resistant, right? It's stable compound, number 1. Number 2, it has a melting point above 300 degrees centigrade. So yes, the method of polymerization was accomplished, right? And number 3rd was that I needed to find out whether the groups that I'm looking for, that are supposed to be in my compound, in my monomer, are there or not. For that, I used FTIR, that is Fourier transform infrared spectrophotometer, and I found all those peaks that I was looking for in that infrared spectrum of my monomer. And I was very happy. I was very, you can say I was extremely joyed. I was extremely, I was the happiest person on earth, because I went through so many steps, and after crossing all those steps, I was able to get my product. So in this way, I synthesized my compound. So this was something beautiful I shared today. So this is how I simply prepared 4,4-methylene bisphosphorylaldehyde, which I abbreviated as MBF, and I was successful in preparing my first monomer. And then I went through all the process of its, confirmation that whether my monomer is actually 4,4-methylene bisphosphorylaldehyde. I recorded its CHN, that is carbon, hydrogen, nitrogen, and through analyzer, I calculated its CHN values, and yes, they were just the perfect. I got the perfect results for carbon, hydrogen, and nitrogen, and oxygen. For CHN, O is also there, so you can also detect O also. The percentage of O can also be detected. But I detected all the 3 percentages that were, what I was looking for. So the CHN and the melting point, the CHN and the FTIR, it confirmed the formation of 4,4-methylene bisphosphorylaldehyde by following this wonderful experiment, by following all these wonderful steps. Though they were a bit tiring, they were a bit, you can say, challenging for someone new, someone who is just performing this experiment for the first time. It was a bit difficult, but yes, I did it, and I was very happy at that moment that I got my product in the end. And I think that was the best moment in any researcher's life, that you ended up what you were looking for with, right? So I hope you like my video. You will enjoy it, and you will share with your friends, and you will share with those who are passing through this research journey, who are interested in forming the monomers and the polymers, or resins, who are on the same track. So maybe this would be a little bit helpful to them. Maybe they will get some knowledge. If I forget something in this whole process, so my due apologies are there, but I try to explain as much as I can to make you realize that how a monomer can be formed via this method by Marvel and Torquoy. So I hope you like this video. So thank you very much. See you next time again with another series, because now it's a series of monomers. So I'll be coming up shortly with you with some other, beautiful monomer with something new, with some other, technique I will use, and I will show you how to prepare the monomer by some other methods. Thank you. Bye-bye.